Hi everyone, Alec from nTopology. Today I want to talk to you about mass and weight saving calculations in nTopology and how you can easily incorporate this into your workflows. So today we're going to import a CAD assembly. I've identified a component within that CAD assembly that I want to volume with Lattice and also perform a shelling operation to. And then finally, I want to calculate our mass and weight savings so we can get a nice quantitative result of how our design is going to shape up and maybe what materials we should choose for printing. So today we're going to focus using the mass properties from bodies block as well as the weight savings block. First, I want to give a quick shout out to Nagy for making this nice helicopter rotor assembly. This is something that's, going to be perfect for what we're doing today in nTopology. And in this notebook, right, I've actually identified a few components that I thought would be good candidates for lightweighting. And, we want to reduce rotational mass. So, things like this blue highlighted component as well as the center component could be large masses that are rotating at high speed and could obviously benefit from some lightweighting. So you'll see in this workflow I have set up, I'm imported a part, I'm converting our component to a implicit, I'm using our shell and volume lattice block. But the most relevant parts to this is we're going to be using our mass properties from body as well as our weight savings block to determine what's our percent weight savings over our solid component that we began with. So let's get right into the workflow, and you'll see I have this instance of nTop open but not at full screen. And the reason I wanted to show you this is we can actually take our SolidWorks file and I can just drag and drop him into my notebook, and nTop is going to import the part. This is something I use frequently with customers and I find it very helpful. So you'll see we've imported this part, and I can use the hotkey Z, which is going to make it zoom to the right fit ratio. And we'll just find a good part that we want to perform our lightweighting to. So in this instance, right, we want to convert this center body into an implicit. And I did that by double clicking, right click, convert CAD body to implicit body. And now if I use the hotkey I can actually isolate this view, and you'll see our implicit body is right here. And I'm going to go ahead and name this original implicit. And with our original implicit, right, this is going to be the body that we're going to perform our shell and volume lattice operation to. So up here we have type in shell and volume, and you'll see right here we have our shell and volume lattice block come up with a nice description. And it says shell and implicit body and fill with volume lattice. That's exactly what we want to do. Now it's asking for that body. I'm going to use our kind of quick smart lookup for usable components, and that's going to be double clicking this input, and it's going to give us a bunch of inputs that we can use. And this is nice when you're just starting in the software, right? So here I have an original implicit, which is what we called our body from CAD. And now we are able to define what type of lattice we'd like. So let's go ahead and do body center cubic. And then we can look at this and say, all right, this is pretty small. And I know this is a small component because if I look at my ruler down here, it's actually around 80 millimeters. All right, so we have 80 millimeters defined, right? And with that, we can try to think of something that's printable. So something that's printable is going to be around 4 by 4 by 4. And of course, we want to define a lattice thickness. Our lattice thickness is going to be around 1 millimeters in this instant, and our shell thickness is going to also be around 1 millimeter in this instance. So I'm just going to click on this, isolate the view so we're only looking at this shelled and volume lattice, and I'm going to use the hotkey X. Now X is going to give us a nice cross section of our component, but I want to orient it towards me. So let's go ahead and make this nice and oriented. And as I start to go across our part, you'll see we have a nice lattice infill, and this is going to be substantially lighter than what we were working with in the beginning. Now you'll also notice that with nTop, I'm able to define a blend radius, and this isn't going to be necessarily a shelling in volume lattice how-to, but just to show you how fast nTop is, we can look in here quickly, and where I have blend radius, we can just go ahead and make that 1. And what this is going to do is make fillets right on our wall here, so we have extra strong bond of our material where we won't have any possible delaminations in print, and that's just good practice. So let's just come out here, looking at our part, and now finally we want to do some calculations. So we're going to do our mass properties from body, and this block is going to give us our mass from the implicit that we just made. So here we can define the body that we want to find the mass properties of, and that's going to be this implicit body 1. So let's give that a little bit better name. So we'll call it latticed body, and we're going to just right click, make variable. Now I can just take this guy and drag him in, or I could have alternatively just double clicked here, and it's going to ask for what type of body we want to find the mass properties of. We could do our lattice body or our original implicit. Let's do the latticed, and it's asking for what's the density of the material you're using. So maybe you have a proprietary material in-house, or maybe you have something that you're working on that's pretty standard. In this instance, we're going to go with the 6061 aluminum alloy, and I know that's 370. So this is going to now run, and if I go into our properties tab, right, we can see our mass is listed here in grams. And what I want to tell you is that we're not limited to just having this as our input, right? I could right click, make this a variable, then I could right click, duplicate this variable, and let's call this guy not just density, we'll actually call it another material, right? So we'll call this one Ti64, and this will be our 6061. And for Ti64, we'll change our density. And what we're able to do now is I could take these and drag and drop them in. So for example, I'll put in our Ti64, and now we're going to have a new mass properties block, and you can see this chip here called mass, and that's going to give us our mass again in grams. So pretty nice. And then finally, what's most relevant to people that are just working into this and saw this nTop live is, right, we can just click weight savings, and because we had such good naming when we were defining our variables, this will be again super simple. We can choose our lightweight body. Our lightweight body is going to be our our latticed body, and then our original body is, you guessed it, going to be our original implicit, and this is going to run. Now nTop is going to tell us our percent change in weight savings. So you can see we have a 27% weight change, and that's pretty drastic for a rotational part, especially a flying part. Of course, the mass matters a lot, and you can see that with nTop. Not only could you perform this with this RC helicopter rotor component, you could use this on a UAV, you could use this on a small aircraft, you could use this on one of your desktop parts you have on your desk. Is a pretty nice workflow, and of course these are already built into the software. So if you have any questions, please let me know. I'd like you to go ahead and look at this file, go ahead and play with it. I'll have it nicely commented for you in the link below, and please reach out to us. Again, my contact information's in the beginning of this slide deck, and I'm happy to talk to you about your application. Thank you. Have a great day. Bye-bye.